Okay, I guess we can get started. Welcome to the Luohan Academy webinar. My name is Ginger Jin. I'm from University of Maryland. Today, we're very happy to have Dr. Christian Catalini from MIT. Christian is expert in cryptocurrency. He has founded MIT Cryptocurrency Lab. I'm sorry, Crypto Economics Lab. I should get that right. And he's currently a research scientist at MIT. He has very extensive experience both academia and industry. He has taught at MIT for many years. He co-founded LightSpar. He co-created Libra and was a head economist of Meta's fintech branch. He also actively engaged with regulators in many countries and advised many private firms. So with that extensive experience, we're really eager to hear what he has on the economics of artificial general intelligence. Christian, all yours.
Thank you so much, Ginger. It's a pleasure to be here to present the paper that's co-author Rick Xiang, who's also on the call, and Jane Wu from UCLA. This is a little bit of an unusual paper, and so the presentation format would also be slightly unusual. The paper was meant to be useful both to academics, but also to practitioners, to startups, and industry players grappling with some of the consequences of near AGI or AGI. And so I will actually try to spend the first part on giving you an overview of the moving parts of the model, but more the intuition than the actual exact mechanics of the model. The model is actually very, very simple. And then if we have time, would love to discuss, what are the, takeaways for individuals, for firms, for policymakers, if you take some of our assumptions seriously. This was a paper that was born out of a desire to really trying to understand what does the future look like. Now, AGI is a very controversial term, artificial general intelligence. Some argue that we already have forms of artificial general intelligence in some of the latest models. They've clearly met and exceeded human capabilities on many dimensions. But as we know, that frontier is very jagged, right? So these models seem to perform extremely well at some tasks and not others. And our intuition, to give away kind of the essence of the paper, is that the reason for that jaggedness really boils down to a very simple thing, which is measurement. Um, Many have come up, I think, with a number of really interesting explanations for what is kind of the scarce input to artificial intelligence. Definitely Agrawal, Gans, and Stern have some of the most influential books and theory on all of that over the last few years. But one of the items that we struggled with was really quantifying some of these terms that people have used when discussing AI. Judgment, taste, curation. You see them repeated all over the internet in the last few months as people are really trying to cope with what are the consequences of AI. But they're very imprecise terms, and it's very difficult to say what is judgment, what is not judgment. So we wanted something that could be very surgical, very precise, and we landed on anything that can be measured. So if you take one thing away from the conversation today is that we believe that as soon as something can be measured, it will be automated. And if you take that very simple assumption to its limit, it really gives you a roadmap for understanding what is becoming abundant, what is not becoming abundant. So let me give you an overview of the framework. As you all know, in economics, I mean, this is really not a surprise. When something that used to be a bottleneck, about for 300,000 years, cognition becomes immediately available on tap. Inevitably, something else that used to be a complement to it becomes, the scarce limiting factor. Um, Ironically, if you look at the history of technology and institutions, everything we've invented, from wages to credentials to firms to markets, are really mechanism for rationing what is limited human cognition, limited human bandwidth, limited rationality. And so, what does the future look like when suddenly we do have some type of cognition, some type of alien intelligence really available to us on demand in exchange for compute and energy? Well, as it turns out, and this is really the essence of the paper, we believe the true bottleneck in all of this is going to be verification. Now, what is verification? Again, we have a narrow definition of this, which is what humans really apply on top of the agentic output to ensure that is really aligned and follows the original purpose. And verification is closely tied to measurement in the paper, and I'll show you more of that in a second. So again, as suddenly intelligence becomes abundant and we can apply it to a number of applications, problems, and domains, we believe that for many of these domains, especially for domains where verification is not simple or not trivial, things get a little bit more complex than they are today. Now, the reason why people are looking at the recent progress and also the recent claims around recursive self-improvements and really worried that this is going to kind of pretty much take over every domain is that we're extrapolating from what happened in computer science or math or other domains where verification is cheap, easy, and can be kind of scaled up just with compute. If you think about unit tests or anything that can be done against code, to domains where actually verification is a lot more complex, there's often a longer time lag, and we don't know what the correct answer is just by running kind of code. Um, Now, what's interesting is also that in the AI space, for those of you that have been following closely, recent developments like those advanced by Dr. Fei Li at Stanford around word models may really break through this final frontier because word models are able to work through hypothetical, counterfactual, and essentially simulate entire scenarios. For now, they're mostly applied to robotics and navigation in the real economy. But you could imagine word models being applied also to economic systems, social systems. And if that is true, then even verification, will become cheap and abundant in many domains like policy or business strategy or entrepreneurship, where today, of course, LLMs cannot really substitute human judgment, curation, or taste, whatever you want to call it. So um, this story of verification, once you focus on it, you realize that the entire evolution of recent AI technology really follows that pattern. So we started with things that could be verified in seconds. Think about an answer in a chat, except hallucinations, of course. Images, code, math. These are all domains where verification was really low cost. But now we're entering and applying this technology also to domain where those rules may not apply. So it's also important from a policy perspective to think about what might people underinvest in if verification is indeed the scarce bottleneck. Uh, After we published this paper in February, I think this theory that verification is really the critical bottleneck has made its way through industry in a number of shape or forms. Recently, for example, Satya Nadella, who leads Microsoft, wrote a piece where he essentially makes the point that the verification infrastructure is the core new intellectual property of the firm. Um, Tim Arford in the FT, for example, said, the danger that AI really produces a plausible slop is really great because it may outpace our capacity to check. And that's essentially our core thesis of the paper. Sarah Guo, who is a venture capitalist, called this the untrainable. So essentially dimensions that cannot be measured, which is essentially also our thesis. But you're seeing now this being supported by how the industry has really responded to some of our intuition. Now, what's the environment right now? Execution is really accelerating. There's reasons to believe that these models will soon write the next version of themselves. And so we're going to trust AI to really kind of build AI prime, so the next iteration of itself. We're seeing, even in the labor market, early signs that, especially for early career workers, this is the famous Canary paper by Brynjolfsson and others, seem to be struggling with occupation. I think we really need better data and better measurement to know if that's actually what's happening and if AI is actually the driver. But it's an interesting one to think about if our theory is correct. Um, But I'd like to flag that it is clear that these agents are being given longer and longer tasks, where we essentially trust them more and more with entire code bases, with entire set of decisions, where we're delegating, almost like in a classical principal agent design, more of our work to these new tools. Now, um, how do we partition work? We partition it, as you can probably guess, not with routine versus not routine work, skilled or unskilled. We're really narrowly focused on one single dimension. Which part of your job are measurable versus non-measurable? And we'll get back to this, but this is kind of the core insight here, which is that everyone's job is a composition, of course, of many different tasks. Some of those tasks can be measured versus not. So you think about driving or a job that involves driving. Driving is a solved problem, we can probably say, from an AI perspective at this point. Self-driving cars are safer than humans, per miles driven. And so that part of the job that's now measurable, just with vision, few sensors, and enough data has been taken away. And soon, although it hasn't truly adopted and diffused through society, is one that will go away from those jobs potentially in the long term. Of course, wages also play a factor, and so it depends on the relative cost of the solution relative to the job. Uh, but for many other jobs, I think we're already seeing it. We're starting to delegate anything that's kind of grunt work, that's repetitive, to the machine. And the reason is because the machine has already measured and has absorbed enough data to really replicate that part of our job. Now, the part that we have not outsourced yet, imagine generating a piece of text or a code, is really the non-measurable. So, what is the non-measurable in this context? Is anything that we can do, and again, this is why it relates to judgment, curation, and taste. After we see the output, to really decide, is this output correct? Is it up to par? Does it reflect our original intent? When you think about what's happening in that moment, we're really applying the weights in our brain to that output and deciding, does this meet the bar? So why are you using your weights in that instance? Is because if you think about what every individual is, since birth, they've absorbed and seen a lot of situations, a lot of circumstances. They've learned to distinguish, for example, good research from bad research, good approaches to R&D from bad approaches. Or if you're a medical doctor, you're able to distinguish, right? Patients that show the same symptoms, maybe there's nuance around them. Experts have seen out of distribution events that allow them to really calibrate what the world is showing them and essentially apply their own expertise to that situation. That's the part that's not measured. But as we will see, as we perform our jobs, as more digital trails capture our intuition, our decisions, our corrections, then of course you can use AI to train on those decisions and also displace that higher level of non-measurable work. So it's almost like a tide that is rising. As we capture more and more of these non-measurable acts and decisions, we can also displace what used to be kind of, exclusively human. So in the paper, the automation frontier is really two racing cost curves. There's the cost of automation that really depends on compute, on data, on new models being trained. And this is kind of the one that's accelerating really rapidly. And then there's the cost to verify that for many domains is really biologically bound. It really still requires a human to spend time and attention. Now, what's interesting is that the way we think about agentic labor entering the economy is that we think of it as only useful if it's actually being verified. And as you will see, there's an externality in our model where when agentic output is created, but nobody verifies it, imagine what's happening right now, right? So many companies and many CEOs around the globe have been essentially bragging about how many lines of code have been written by AI, with some stats above 75%, right? If you think about it, that also means that 75% possibly has not been fully verified. And so maybe carrying some technical debt, some cybersecurity debt, some additional problems that will be only revealed later. As we're all tempted to ship AI generated output without full verification, what we believe is we're also introducing in the economy what we call the Trojan horse externality. Essentially, XA in the model, which is going to be a parameter that's essentially counterfeit utility. Unlike pollution in a traditional industrial model where you can separate it right from production, even visually. Here, this XA is essentially looking like the real result. So slop is a really good example of XA. It's probably a simple one to spot, right? Because it takes a very low verification cost to verify that a piece of writing, for example, is just slop and it's not high quality content. But when a developer ships 100,000 lines of code that have been written by 1,000 agents, which, by the way, is what's happening right now in production in many firms, it is very clear that there might be some preferences, some decisions that the AI has made that may not be fully aligned with human preferences. And of course, this becomes much more existential as these models become more capable and we trust them with more and more of society. So keep an eye on that Trojan horse externality because it's going to be important from a policy perspective. So what are some of the key results? Well, what we show is that inevitably these machines are getting more capable. And so without deep investments in verification infrastructure and new technology, including human augmentation, so if you think about those brain-computer interfaces that are being implanted in very experimental fashion in some humans at this stage, what inevitably happens is that the models are getting better because they scale with energy and compute. And so far, the scaling laws, even within the LLM paradigm, even if we don't think about word models, have been going very fast. Inevitably, we're shipping more and more agentic output that's unverified. And so that gap between what the machines can measure and what we can measure keeps increasing. Second, we've already entered an era of what we call measurability bias technical change. So after decades of skill bias technical change, we predict that rents are really migrating to unmeasurable domains. What are measurable domains? There's many types. If you think about frontier R&D, R&D, of course, is unmeasured at this stage. Now, AI will be used extensively to make discoveries and make new innovations. We argue that most of those will be recombinations of existing ideas. And some of those will be very creative, some of those will be very impactful, but you will still need humans to go and measure new things that haven't been measured, that haven't been really even fed to these models to make predictions and kind of recombinations. Second, we predict that it's going to be quite important to be either individuals or firms that can absorb liability for machine output. What do we mean? Is that if true economic value is really the composition of agentic output plus verification, then the best firms on the planet will be the ones that will be able to also ensure the potential side effects. So they will not just sell you, say, the agentic output. And by the way, we're already seeing this. They will also come and insure it because they're better telemetry, they're better data. They know when things will go wrong, and so they can insure that risk. Some companies that I'll show you, for example, in the slides, have already started insuring the coding agents, saying, look, if the agent does something terrible, we will insure it up to a certain amount. So this new model of liability as a service, we think is going to be quite important in the agentic economy. Third, from a labor market perspective, and this is kind of aligned with some of the recent findings, we think that the loop with the human inside is dynamically unstable. So it's eroded from below for the juniors, because now, if you think about it, these models pretty much have the same knowledge of a junior entering the job market. When they come out fresh out of college, if they haven't done many applied labs or other more applied exercises, they pretty much know what's in the textbooks, plus or minus, right? And so they're essentially challenged by the machine. The machines can do the job of a junior marketing person or junior lawyer. Of course, they cannot yet reproduce the senior people in those professions. But this is a challenge because, of course, if you don't get that entry-level apprentice period, you can never develop into a more sophisticated senior expert. But there's also another type of erosion that affects the top experts. If you think about it, this is already happening. The top labs have been hiring top experts from the financial services sector and the legal sector and many other domains to train evals to essentially, create the loops to tell the machines what does good verification look like. As that happens, what we call the codifier's curse is playing out, which is essentially saying, as the top expert do their job using AI, they're essentially creating the traces, the evals, and the information points that allow them to be also disintermediated. Now, the simple version of this is what already happened with image labeling, another very simple task. AI labs don't need that anymore, right? So entire companies like Scale AI were created out of the idea that you needed people to label images, label text, classify things. Models can already do that. So that's a very simple example of the codifier's curse. But I think we're going to see this moving up the value chain as people inevitably use AI, because of course it augments their capabilities, but it also is a threat and can displace them. Now, from a more technical perspective, and this is relevant for the AI safety literature, what we show is that alignment of these models is not just a one-time thing. You need to continuously steer these AI models to ensure that they really follow human preferences. And the intuition is simple. If what the model can measure is different than what you can measure, then the overlap between you and the machine keeps shrinking. And without overlap, we really don't know if these models are introducing weird preferences into the decisions. Some of this has already been observed in the wild, where models develop certain weird preferences in training. Some of these are just idiosyncratic or driven by the data that they've absorbed, maybe from the internet, and then they react really in strange ways in very idiosyncratic context. That's clearly an error at this point, but you could imagine these models eventually taking kind of a life of their own, having their own preferences, and that being potentially very detrimental if we cannot even know that this is happening. Uh, and last, in terms of key results, from a policy perspective, it's really important for policymakers and others to think thoughtfully about that externality, right? So the counterfeit utility that everybody's introducing in the economy right now, um, it has a real cost. The problem is that that cost is often revealed only later on. So if you think about the simple example of lines of code being shipped right now without being verified, they could introduce massive, systemic risk in the economy when that code goes wrong. And so we kind of preview two potential scenarios. One which we call the hollow economy, where there's a lot of these accumulated debt and hidden liability driven through, the private incentives of just adopting AI without considering some of the societal costs. And the more positive version, where of course we use these tools to augment the economy and we, encounter a period of growth and prosperity. So that's kind of the paper in a nutshell, in case I ran out of time. I won't delve into kind of how this adds to the literature. Again, a lot of this is in the paper, which you can also access as an MD file, so you can throw it into your favorite LLM and have a conversation about it. I would just say, again, this is a paper that builds on a lot of work that's been done, and in a sense, I think is actually consistent with many of the frameworks, just by adding kind of a much more narrow and precise definition of where the bottleneck really is. So we try to operationalize, for example, judgment. We try to operationalize weak links in a way that's very pragmatic and practical. So again, I'll try to give you an overview of the framework, and then really to focus on the actionable strategies. I've already previewed kind of the tension between the hollow economy and the augmented economy, so I won't slow down here too much. But I would say that's probably the main challenge from a policy perspective, is really thinking through how do we ensure that private firms and participants really take into account the fact that as the technology is deployed at scale, it could have some meaningful side effects. And some of these, again, don't need to be the doomsday scenarios. They can be very benign errors, but they could still have a massive impact on the economy. I've already talked a little bit about measurement versus non-measurement. In the paper, we really think of this as in terms of time. For now, what I just want to emphasize on this slide is that we believe that essentially everybody's job can be really divided into two bins. One is measurable work. And again, think of these as tasks where the environment and the reward can be measured and codified, right? So anything that you do today that could be tracked and shown into numbers. Um, People tend to think of this as routine, but it's a bit different than that, right? So there's a lot of routine work that cannot be measured accurately. And then there's not measurable work. And this is kind of the unknown unknowns or the Knightian uncertainty piece. Um, if you think about it, yeah, from a research perspective, right? So there's a lot of repeatable tasks that you do, especially in empirical work. But then there's all the steering and intuition of like what to do next, what to look in the data, what kind of tests to run. And some of those can be automated, but some of those are really kind of the domain of the expert. And again, think about the difference between a young PhD student um, and a senior faculty. Typically, it is all on the non-measurable work. Looking at the same data, looking at the same questions, they will have an intuition of where to go, which might be slightly different on what to test. That's kind of the crux of the model. Now, how does this play out in a very simple spin-off of Romer's endogenous growth model? You have the classical, output that's driven by capital, public knowledge, A, and what we call effective labor. And effective labor is a little bit different here, but really captures the idea that labor is a Cobb-Douglas aggregate of your non-measurable components and your measurable ones. Again, one could argue on the Cobb-Douglas structure, it just happens to be a very simple one, but that complementarity is sort of important. And if you look at the two key components, these are the ones you should really pause on, LNM and LM. The non-measurable work is really kind of the product of your accumulated stock of experience. Again, think about the senior faculty that has seen a lot of research papers, has seen a lot of empirical work. I've seen a lot of really out of distribution instances, right? So if you think about what makes an expert different than a junior, is the weights in their brain have been calibrated in a slightly different way. They know what to place attention on, what to ignore, that accumulated stock then gets amplified by just the number of hours you spend on the task. And so if you think about it, when it comes to non-measurable tasks in the economy, the value of hiring a top AI expert, we're seeing now labs paying some of these individuals hundreds if not billions of dollars. The value of their S&M is really a multiplier on their time. So a single hour by a top expert in a domain, a top doctor, a top lawyer, a top academic, can be a lot more effective, of course, than a junior. And so that's how that component works. And then there's the measurable work. So how does measurable work work? This is really where the competition with the agents, with the AI, is taking place. Here, humans and agents are fully rival. And the way they're rival is through what we call the verified agentic labor. So for an agent to be a real substitute for human work, even measurable work, it needs to be verified, right? So if you think about, again, the self-driving example, a car that drives itself, but can crash at any point in time is not a substitute for a human driver. When the car is safe enough and the agentic output of a Tesla on FSD, a Waymo, or any other device is verified and safe, that's when it's really a substitute for human labor. And so if you take one thing away from this slide is that unverified agentic labor does nothing to the production, right? It's just slop, and it just accumulates systemic risk in society. If you think about text generated by an LLM, if you just write a simple prompt and have it write an article or a paper, it's probably going to be very close to slop because you haven't spent any time verifying. So it is not a real substitute for the real thing. Now, I think we're already seeing this, by the way, in the wild. This graph tracks mobile app releases in the app stores over usage. Also, because the cost of experimentation has gone down, you're seeing massive explosion of new apps, but not a lot of usage, right? And that really hints at the fact that real economic production often requires complements to make these things actually useful, distributed, and paid attention to. Now, in the model, we're really racing to two frontiers. One is the cost of automation, and one is the cost of verification. And as I've already hinted at, the cost of automation is the one that's kind of going exponential. and the cost of verification is much more bottlenecked. So let me spend a little bit of time describing these two curves, because once you have the two curves and the measurement gap, you kind of know where the rest of the model goes. And then we can talk more about the implications. So the cost of automation is, of course, harder when the problem has very, very high dimensionality, right? So a very complex problem is harder to automate. That's a very simple intuition related to the entropy of the task. Now, of course, more compute, better data centers, more data centers, better, NVIDIA chips, Huawei chips, given the recent developments, right? More of that leads to more automation. And the better the knowledge stock, so if you think about A in Romer's model, all the public information, but also proprietary knowledge. So, for example, all the records of a law firm, all the records of financial firm, amplify automation. And so the same firm using the same model, Claude Fable in the hands of a law firm with lots of historical data versus one that's brand new can automate a lot more. Those are the drivers of automation, and they're all pretty scalable. Um, on the verification side, I want to point the TFB item. That's the feedback latency, right? So how long does it take for us to discover if the decision was the right one? If you think about code, it's milliseconds, right? You can run a unit test, you can run tests against the code. But if it's an investment decision, a startup decision, a policy decision, some of these things can take decades. And so the longer the feedback latency, the harder it is to verify that task. And in a sense, you're relying on the human judgment behind it. Now, again, when word models become real, if they become real, this will change, because essentially you'll be able to simulate all these scenarios at very low cost. But right now, this element of verification is really important. So if you think about different jobs that have long feedback latency are definitely more protected at this stage. And then what else comes into the verification cost? Well, of course, already experience. We talked about that, right? So you can think of human experience as compressing latency, because the expert is essentially thinking through the future scenarios already in their brain. They've already seen a lot of cases. Imagine a medical doctor. They've seen countless patients show up with the same symptoms, and they already know, okay, this is actually something that needs surgery versus not. And then wages, right? So wages, of course, matter. And here you're already seeing the signs of almost like a superstar economy, where as capabilities go up and up, the experts that remain become a lot more valuable. This is already happening in AI, right? Where the top AI experts are really, really valuable, because they're the ones that can really verify the progress of the machine. So what's the asymmetry here? Well, abundant compute, better models are really driving CA down. So it's easier and easier to automate more things. And CH, of course, is instead bounded by biology, right? So unless we can augment ourselves, it's much more limited. Which leads to the measurability gap that I was talking about, right? So the overlap between what humans can measure and what agents can measure, that's the safe zone, right? Whenever we can understand what the agents are actually doing, what they're measuring, what their decisions are driven by, we can also verify them very easily. But as machines can do a lot more, this gap between us and the machines keeps increasing. I think we've already seen it with driving, right? Where now, with a very limited number of sensors, for example, the Teslas, just with cameras and AI, can really replicate human behavior with a lot of less inputs than before. That really partitions the economy into four quadrants. So on this graph, you have the cost of verification on the vertical axis and the cost of automation on the x-axis. Let's start with the area of displacement, right? So this is what we call the safe industrial zone, where AI can really deploy it at industrial scale. Here, the cost of automation is fairly low. And verification is also very low. Coding is a good early example, some parts of coding. What this means is that, of course, all of this will be automated and the machine will verify it too. So really no humans involved. So any job in the safe industrial zone is really a risk, or any job with a number of tasks in the safe industrial zone is really a risk. If the cost of automation is really hard, right, then you're kind of what we call the artisan zone. Here, it's just too expensive or difficult to automate tasks, and humans retain comparative advantage. But of course, as capabilities increase, of course, that line will keep moving and eating more of the artisan zone. At the top right, you have what we call the pure tacit zone. Here, not only tasks are really hard to automate, but they're also very, very hard to verify. So this is anything that really relies on reputation, relationships, social consensus, right? A lot, big parts of the economy end up being status games or social consensus games. Here, there's almost like no right or wrong answer. It really depends what other people really converge on. So it's very idiosyncratic. This is a zone that's pretty safe from automation. But then there's the red zone, which is the one that one should be worried about. These are tasks where, automation is kind of cheap. Actually, you can automate it. Um, but verification is expensive or not feasible from a budget perspective, right? You could technically review the 100,000 lines of code that, Claude or Codex have just sped up. But you're not going to do it anymore. And this is where, you may accumulate some major economic blind spot. So you've already seen that essentially this gap widens mechanically. And so what's kind of interesting is that here we're going towards a future where more and more agentic activity will really be deployed without human oversight. And that's where policy can matter. I do think that there are instances of verification technology or better technology for verification that can really keep us closer to the machine capabilities. And it's going to be increasingly important, I think, for keeping control of the economy. I see a question in the chat. Let me just read it. Yeah, I mean, very briefly, in the interest of time, I would say that I think that this will keep advancing. So the question really centers on, what's the purpose of this to some extent. The technology will keep advancing and taking more and more of the capabilities. And so it's important to, I think, to understand what kind of complements can we develop from a societal perspective to ensure that it's deployed in the most effective way possible. I'm going to keep going a little bit because we don't have a lot of time left. And then maybe we can leave the last 10 minutes or so for live Q&A. Again, this is all over the headlines, at least here in the US. I imagine very similar in other parts of the globe. Started with 30% of code being written by AI. Now it's over 75%, for example, at Google. Spotify claims that, the top developer haven't written a single line since December. And then, of course, Anthropic warning a few days ago that, most of Claude's new version will be written by Claude. So this is essentially 100% AI. I've already hinted at some of the challenges. Again, the juniors not finding a job because a lot of what they do is measurable work, right? If you think about a classic intern or apprenticeship period, that's a period where essentially you're just participating in the process and learning by exposure to the expert. You're seeing how they make decisions, you're being exposed to these non-measurable moments, and then you absorb them and build your own expertise. I've also talked about how experts are really tempted right now to monetize their tacit knowledge. It's very, very profitable for top experts to do this and create evals. But in doing so, they're essentially displacing themselves. And then, as you can already predict, if we're deploying more of agentic output without verification, inevitably, we're kind of aligning less and less with the machines. So I'm going to accelerate here in the interest of time. Again, the model goes into a lot more depth on what's going on here. But if the canary result is confirmed by follow-on research, again, it's very early to know if this is AI or something else that's driving some of the struggles in early employment for juniors, then it would be totally consistent with kind of our theory of verification. Now, what are some countervailing measures? So when it comes to, for example, the missing junior loop, really briefly, what we show is that again, measurable work is going to keep contracting over time, right? And so the models will be able to do more and more of that. If we don't invest in training individuals in a novel way, we really risk cutting kind of the bottom of the ladder. And so those individuals will never develop into fully fledged top experts. They will never be competitive. So the model has this concept of T-SIM, which is essentially learning that happens through simulation. where essentially you're trying to substitute what used to be an internship, an apprenticeship period, with an environment maybe that is created by AI and exposes individuals really rapidly to the frontier. So this is definitely a policy lever. And universities should probably think hard about this. How do we create high fidelity simulations of the real world so that if those entry level jobs really start disappearing, we can still train people for the higher level work? And the bottom line of this graph, which I don't have the time to go into the details of, is that essentially under this adaptive policy, you can always keep ahead of the model developments and keep humans, of course, relevant and in the loop. Um, Now, what's kind of interesting on the top expert is that it's a total prisoner's dilemma, right? So if I'm a medical expert and I don't want to help a foundational lab develop better evals for medicine, for example, somebody else will. And so as they do, it's essentially eroding what used to be the measurable in that category and pushing everybody up the frontier. So I would say the piece of bad news here is that inevitably we all have to move up the intelligence value chain. Now, the good news is that the same tools, of course, that AI proposes can also be used to do that. You're already seeing this in the wild. Data labeling was a hot thing in AI just a year ago. It is not anymore. Now you're seeing companies like OpenAI, for example, uh, hiring for Wall Street, hiring analysts, hiring experts to build business models and financial models they can train models on. Actually, this is just as of yesterday. Movie studio A24, which is known for very high quality movies, just did a partnership with DeepMind. As you can see, this is a very creative endeavor, but even the creative industries are not really exempt from the top expert participating and, of course, potentially also creating their own displacement on the side. I'm going to skip the part on alignment. One thing I want to actually pause on is that often you hear, as a response to our focus on verification, that, well, can't AI just verify AI? And even without looking at the math, the intuition of why that is wrong is very simple. Of course, we're going to use AI to verify AI as much as we can. But inevitably, at some point, there's going to be parts that the AI cannot measure. And so if we trust AI to verify AI, there's going to be a correlation in terms of blind spots between the doer and the checker. And this is particularly problematic as we're entering probably recursive self-improvement. Maybe we've already entered it. Essentially a regime where AI is writing itself. If some of these errors compound, get correlated over time, we may be deploying in society potentially very dangerous models and applications. And I've already covered kind of the Trojan horse externality. Again, here, just to give you a few examples, right? What could be if someone, I think there's someone not muted on the call. If they could mute themselves, that'd be great. Thank you. What are good examples? I've already talked about code, so a vulnerable code base, right? A code that passes every test, but then maybe has a cybersecurity flaw. You think about AI being applied to education, right? An engagement agent that really optimizes on students' engagement and really ends up, with very happy students that don't really learn anything. Karpati had this really interesting point about education in the world of AI needing to be sweaty, like a gym, right, for the brain. How do we ensure that we're not kind of training for engagement versus actual learning? Or for those of you that remember long-term capital management, this was a famous hedge fund run by Nobel laureates and others that eventually collapsed all of a sudden because it accumulated a lot of tail risk exposure. So if we apply these models, for example, in the financial sector, we could easily find ourselves in a world where that Trojan horse externality is accumulated and can be quite dangerous to society. This is already happening, by the way, in every part of the globe. On the left, you have a Chinese example. On the right, you have a US example. A cybersecurity company ended up shipping a private key, a very sensitive piece of material, with their code. Amazon, had to hold a mandatory meeting because there were a number of really major incidents caused by generative AI being used to write code and kind of shipping code that wasn't really reliable. So this is already happening in the wild. In the paper, we also discuss what this really means in the long term. Without going too much into the details of this, we could find ourselves in a scenario where the economy rapidly accelerates. This is not that different than the famous paper clipping example that people worry about in AI. We could have a lot of output that looks like real output, but again, is accumulating a lot of debt. And when that debt comes due, you could really figure out that, oh, we've been injecting into the economy AI preferences, not really human preferences, and that could be a major concern. Um, so, in the interest of time, let me just really emphasize what are the countervailing forces to some of this. Well, first of all, alignment and safety R&D, really important. Second, building technology that can really accelerate mastery for individuals and rebuilding that expertise through synthetic practice to new types of educational forms that really compress the time for individuals to get on the frontier and have a much more rich, understanding of the real world application of whatever they might be trying to do, whether they're a lawyer, an engineer, a business student, or so not. And then verification infrastructure. So we think that in general, anything that lowers the cost of verification, anything that allows us to keep in check what the machine is actually doing. Recently, there's been progress on trying to explain how models come to the decisions that they come. That technology is quite interesting, right? Because it really allows us to shrink the measurement gap between us and the machine. If we can understand what drive a machine decision more carefully, then of course we can also inspect it. We can really make sure that it follows human preferences. Um, Now, as I've already mentioned, not all verification is equal, right? So there's going to be some tasks in society that are really easy to verify, and some tasks that we may feel like, okay, we verified them, but actually ground truth is going to be only revealed much later. That's where the danger really is. Now, Greg Cameron from the Arc Prize Foundation had actually a nice implementation of our idea where he tries to divide ideas at different levels of easy to hard to verify. So if you think about what he calls level one, math, code, formal proofs, chess tactics, very easy for the machine to verify. And then if you go, for example, already at level six, right, institutional verifiable system, how do you really test that a new educational system is sound, or a new legal system, or a city planning? These are policies that have long horizons. They're very difficult to verify. Now, again, word models could make a difference, but right now, this is definitely the domain of humans. In the wild, I think we're also going to see an emergence of liability as a service. This is already happening, where AI companies will also, try to underwrite the risk. And this is intuitive, right? Because the rents, from an economics perspective, really migrate from the simple execution of economic tasks, which are not commoditized by compute, to verification, provenance, and really credible assurance. Are you standing behind your agentic output? Cognition is one example. They're now ensuring the code written by their agents. 11 Labs is the same. They have an audio agent that can do calls, they can do phone calls, and that is also insured, so that if the agent says something wrong, they're essentially the one standing behind that decision. Now, I think what's interesting from a policy perspective is that if we really believe that we're entering an era of measurability bias technical change, it's really clear kind of what individuals need to do to keep staying relevant. And it's also really clear what's happening in society, right? So on the right, you have an example of a startup that's offering to clean up your apartment for free in exchange of being able to record the actions being performed. As you can imagine, of course, this is training data for robots eventually doing this task. And so whenever you see more measurement in society, you can really predict that automation might be next. Now I'm out of time, so I'm going to spend a couple of minutes on actionable strategies. There's a lot more in the paper, especially in section 8. We try to think through, if you believe the model, what does this mean for individuals? What does this mean for startups and firms? What does it mean for investors and policymakers? And so there's a number of playbooks that we kind of derive from the model. Really briefly, for individuals, depending on which part of your task are easy to or hard to automate, or easy or hard to verify, there's a number of roles I think that are going to still important for humans to do. In some settings, like the directors, people will be, essentially navigating, steering agentic intent of many agents. This we're already seeing with companies that are often have only a few employees, but they're using agentic work. Then I think a really important role is going to be the liability underwriters. So these are the top experts that will be able to verify and curate agentic output at scale. Of course, the bottom left is the obvious quadrant where things are easy to verify and easy to automate. These jobs are going to be displaced. And then on the hard on the top right, I mean, these are very difficult jobs, the meaning makers, right? So these are jobs that often rely on social consensus. They're not really objectively measurable. They may rely on human connection, the attention of a human dedicated to you. That's also a very defensible category. Um, Individuals, of course, have to move up the value stack. I've already covered this through synthetic R&D and practice. They have to move from being producers to directors, and often also moving to the non-measurable. Firms, I think, over time will look a lot more like this, with directors of intent at the top, a lot of agentic execution in the middle, and then liability underwriters. These are going to be still human experts for now that really make sure that everything the machines have produced was really following intent. We call this the AI sandwich. I'm going to finish on one interesting tension, right, which is important from a market structure perspective. Many believe that the models would do everything, right? So the models would be able to replicate everything that's available in society. We actually think that that's unlikely to be the case if you believe the rest of the paper. If anything, the bitter lesson by Sutton actually points at the idea that a lot of these agentic capabilities, even the frontier ones, are going to be commodified, and open source has been trailing closely. Some say it's 8 months, some say it's less. Um, so the models are probably not going to be where appropriation happens. The appropriation is going to be more at the verification infrastructure for level. So think about the evals, the proprietary data. Um, and so if that's true, then it's going to be really important who owns that stack. And right now, I think you're seeing a tension between what some firms are trying to appropriate and others, for example, between platform operators like Microsoft versus the foundational labs. um, the crux is really who owns the data that allows you to do the final verification, right? And that, we believe, is actually the one form of network effect that's going to survive under this new regime. And so, if there's one takeaway that's kind of important for firms, I would say, is that firms that can really compound that verification, they can own it, they can protect it, they can compound it over many decisions, are going to exhibit a new type of network effect that we haven't seen before. Many other network effects instead are going to be challenged. And so, you're seeing this where, for example, the AI labs are trying to really capture more of your judgment, more of your decisions, more of your verification, versus others that are trying to bring that in-house. For those of you that have been following the developments in things like OpenClaw or Hermes, these harnesses, these open source infrastructure are essentially putting that control in the hands of the individual. So there's a really interesting tension happening there in terms of verification infrastructure. There's a lot more in the paper. Happy to share the slides. I think I've already covered the conclusions. Really, to close, we believe that economic scale without verification is really not a moat. It's really accumulating depth in many different forms. And again, we do think that if you think about the scarce complement to AI is really the act of verification and the infrastructure that comes with it. So happy to take a few questions. I think there's a few in the chat. Ginger, do you want to prioritize, or happy to also take in whatever order that they're in?
Thank you, Christian, for a very inspiring talk. Just feel free to go with whatever order you want to take the questions. We already have a few in the chat box, and I think Long Chen has raised his hand. Your choice, Christian, and that's which way
Yeah,
you want to answer the
let's take
chat.
the live question first, and then I'll go back to the chat.
Okay. Yep. Long, go ahead.
Okay. Thanks, Christian, for a very fascinating talk. So my understanding is that we are talking about a very critical issue that do not have a clear solution. That is in an increasingly so-called agentic economy. That is, we have to change the workflow of the human beings to surround the agents. How much human beings should be in the loop, and what is the implication? So I think that is a crucial question that people are advocating for this structural change for firms, but actually we do not know a clear solution. The issue here is that I think there is I think it's on the supply side that actually there's a lot of incentive to use the agent to replace the human beings, but actually we do not know the outcome of what the potential damage or dangers of this. I think that is the thing that strikes me most is that you point out this is a critical issue. Now, but I have several questions for this because what's talking about in the future for this for kind of verification value to happen, there's a role for the government and also there's a role for the market. The question here, how will this happen? So there are several questions here. One question is that,
Yep.
in
Maybe
your
in the
view,
interest of time,
how much of the work?
I'll take that first question, and that way we can also answer some of the others. Let me
Got
just
it.
start with the first one. Sorry to interrupt. I would say,
Yeah.
yeah, so there's definitely a role for the government, but I would also say that the market will police some of this, right? And you're already seeing it. The fact that some of these startups or incumbents are ensuring their agentic output is already telling you that they understand that there's a risk here, and to win a customer, they need to come not just with the agent, but also the agent plus the insurance that they're going to stand behind it. Now, of course, there may be regimes or domains where policy is important. And if the liability, for example, is diffuse or the firms will not, recognize it until much later, that's probably the area. So I would say policy versus market, really when the feedback loop is really long, probably policy is a lot more needed. And again, there's a lot more in the paper. I also want to be mindful of some of the questions that were in the chat. So maybe let me try to answer those, and then we can have any other follow-on since we are, I think, 2 minutes from wrapping. Look, on the Cobb Douglas, yes, you're correct. You can make a lot more sophisticated assumptions and make the model a lot more rich. Xiang has also been extending the model, so we're going to have a revision of the paper with some extensions. We tried to keep it simple. I mean, again, the core that we wanted to really surface is the measurable versus non measurable and how they really affect labor if you take this seriously. So that's kind of our decision. On the last question that I see in the chat on the input side, yes, it is true that these models have been trained on a lot of public domain information, and there's all sort of lawsuits going on right now with some of these IP holders, right, that have been, of course, expropriated. Look, I think in moving forward, it's going to have to be different. You're already seeing it. Firms are going to pay, I think, for better measurement on the input side. In some cases, I would expect foundational labs will just acquire companies. They will acquire companies not necessarily for their day-to-day operations. They may acquire companies for their historical data. So I wouldn't be surprised if a major foundational lab will acquire a law firm or will acquire, a financial services firm or insurance firm. And so these data deals, I think, are going to be a lot more mediated going forward. Also, because everything that was public domain or available on the web has already been ingested by every model. Something that's interesting to think about it here from kind of an economics perspective is also that if you think about open source versus closed source, it's almost impossible to stop models being distilled. And so there's leakage, and potentially I think that's maybe good long term for society, but it's also not great, of course, for the owners and builders of new proprietary ground truth. So maybe one implication of this is that we're going to see more vertical integration. If you're able to really do breakthrough new measurement in one domain and do it really well, you will bundle the measurement with the model. And so you'll have a customized model that maybe is really good at a problem. And the reason why you're probably going to try to do that and keep it very tight is because you're really worried of those capabilities being distilled by others. So a lot to be figured out. And I think there's an interesting tension between open source models and closed source ones, even from a security perspective. One could argue that capabilities that are more diffuse, open source, open weights actually can help with ensuring infrastructure, ensuring that everybody is ready for some of the side effects of AI. Probably some of the biggest concerns right now are around biology, actually, rather than software. If you think about biological material and how it could be abused, it's a major concern. And so, again, there's concerns about the models doing weird things, but there's also concerns about bad actors using these models to do bad things. My take is that actually open source really helps the defense side of the equation because again, even the proprietary models can be easily jailbroken and accessed for bad purposes. I'll pause there. I know we're at time. Happy to take maybe one more question if there's anyone else that wants to ask a question before we wrap.
Thank you, Christian. Long, do you still want to ask your second question?
Yeah. Well, I think the problem is bigger than this. I see a huge incentive issue here is because the companies they actually have good incentives to realize the profits, whatever the result, using the agents. But actually, this is allowing when the agents taking more responsibility. Here, you actually do not know what will happen. So I think then the government needs to chip in this, but it's not right now. The boundary is very blurred. Probably this will become a huge issue here, but I can see that this become a critical problem in this agentic economy. So how much human should be in the loop, should be responsible, and it's not just about being responsible because it's a market-driven force. So this is a fascinating question. That's what I learned most from this.
Thank you. No, I think you're absolutely correct. I think the challenge with policy in this domain is also that things are moving so rapidly that, in a sense, without better measurement, ironically, even take
Right.
the job question, right? Is the candidate result real,
Right.
driven by AI? Right now is a descriptive. I don't think we know. And so I think any effort from a policy perspective, actually, if I were informing policy, I would say strive for better measurement, strive for better commons, because the more relevant information is in the public domain, the more clever people will use it to build defenses against some of these models. For example, even in the cybersecurity example, I do think open weights, open source models have been extremely helpful because they allow firms that maybe have not been, included in the mythos to prepare themselves. There's many of these instances where I think the government can do a lot with very simple policies. Education is another one where it's very clear that we need to build new systems where we can't test people the same way we were testing them before. AI is making a lot of that ineffective. Anyone that has been teaching, in a business class knows
May,
that
may
it's extremely hard,
I
right?
chip in with a question? Sorry, may I chip in with a question here? What's the percentage of human beings you think are capable of doing this verification job,
I think you'll be
even with
surprised. I
training?
think a lot more than people think. I do think human beings have many different
Okay,
forms of intelligence. We happen to measure IQ, maybe we measure EQ. I think we don't measure the jaggedness of our own
I
intelligence. And
see.
so if we empower individuals with these tools, by the way, I think last parting thought, I know we're way over time. These tools will allow juniors to figure out way faster what they're good at, what their innate talent is, and to get those reps under their belt much, much more effectively. So I think they're going to be very powerful and very positive agents of change. I know, especially in the West, there's a lot of opposition to AI at the moment. I think in China and other countries, there's been a much more positive reaction to it. I am definitely not of the doomer camp. I do think that if we use the tools right, our young, college graduates will be way, way more powerful, way more talented than we ever were. And so on that note, I think we can probably wrap and thank you, Ginger, for hosting and for everyone else for engaging in the conversation. Happy to answer more questions online. You know where to find me.
Thank you so much, Christian. Thank Luohan Academy for hosting this
Thank you,
webinar.
Chris.
Thank everyone for participating.
Thank you so much.